Hello and welcome to the Toshogu Podcast, where we break down the latest news, breakthroughs, and ideas shaping the future of artificial intelligence. We're definitely moving past the era of simply asking, which AI model is smartest. Today's exploration focuses on the invisible infrastructure being built right now to turn AI from passive chatbots into autonomous, enterprise-grade agents, how they get secure permissions, the completely new hardware architectures designed specifically for their speed, and how they're effectively compressing entire business workflows into a fraction of the time. Let's begin. So I want you to imagine the scenario for a second. An employee leaves your company, right? They're gone. But a digital ghost of their security badge is somehow still active.
Oh, yeah, a classic IT nightmare.
Right. But it gets worse because that ghost is being used by an experimental AI agent somewhere on your network. And it's just quietly reading, summarizing, and moving your highly sensitive financial documents 24 hours a day.
Just wandering the halls.
Exactly. Just wandering the digital halls. And that nightmare scenario is exactly why the entire AI industry is suddenly, pivoting away from just building bigger brains. They are frantically trying to build a secure nervous system to actually control them.
Yeah, I mean, it really is a massive shift in how we approach computing right now. For the last couple of years, the entire industry was exclusively focused on the models themselves.
Right, the parameter counts.
The parameter counts, the reasoning benchmarks, the sheer scale of the neural networks, But raw intelligence alone isn't enough to actually get work done in a complex, walled-off corporate environment.
Yeah, because raw intelligence in a vacuum is just a brain in a jar. Like if we think about hiring a brand new, highly capable human employee, they could walk into your office on day one as the absolute smartest person you have ever interviewed.
Right.
But if they don't have a corporate directory to know where the files are actually kept, and they don't have a secure key card to physically open the doors, they cannot accomplish a single task.
No, they can't.
They're effectively paralyzed.
That is exactly the situation we have been in with AI agents. You have these incredibly powerful reasoning engines, but connecting them to the actual messy reality of, an enterprise data ecosystem has been a complete nightmare of custom integrations and shaky permissions.
Yeah.
But that is fundamentally changing right now, and the solution is arriving in two distinct halves, which are discovery and identity.
Okay, so the directory and the key card. Let's start with the directory. How does an AI actually find out what tools it's allowed to use without a human programmer pointing it at a specific URL?
Well, AWS just introduced something called Agentic Resource Discovery, or ARD.
Okay.
It is an open specification designed specifically so that agents can discover tools, servers, and other resources across entirely different environments. So we are talking across different cloud providers, software as a service applications, and even on-premise local servers.
Wait, like the physical hardware sitting in a company's basement?
Exactly, the legacy stuff.
Okay, but how does that actually work mechanically? Because usually software talks to other software through some massive centralized hub, right? Like some central API registry that every single application has to plug into so the system knows what exists.
Precisely. And in an autonomous AI ecosystem, that centralized hub becomes a massive, massive bottleneck. What is revolutionary about ARD is that it removes the need to centralize everything first.
Oh, really?
Yeah, it leverages something called the Model Context Protocol, or MCP.
Wait, let's define MCP for a second. Is that basically just like a standardized translation layer? So the agent and the database speak the exact same language, kind of like a universal USB plug for software?
That is a perfect way to describe it, yeah. Before MCP, if an AI wanted to talk to Salesforce, a developer had to write a highly specific, totally custom integration.
Right.
And if we wanted to talk to Jira, that was another custom integration. MCP standardizes how tools expose their capabilities. So combined with AWS's ARD, an agent can dynamically send out a signal and discover what MCP-compatible tools are available to it in real time.
Oh, wow.
No matter where those tools live. It is a decentralized, highly scalable corporate directory.
Hang on, though. I mean, if there is no central registry governing this, isn't that a massive security flaw? Like, if autonomous agents are just dynamically sniffing out servers across different clouds and local networks, how on earth do you govern that? It sounds like a hacker's absolute dream.
It does. And that is exactly the right question to ask, and it brings us perfectly to the second half of the equation. Seeing a system is very different from being legally and securely allowed to touch it.
Right.
Discovery means nothing without identity. And this is where Anthropic's latest move is so critical. They have just made enterprise-managed authorization for their MCP connectors generally available.
Okay, so they are building the secure key card.
Exactly. They are rolling out support for vital enterprise hubs like Datadog, which companies use to monitor their server health, as well as Notion and Slack. But the specific apps aren't actually the main story here. The critical breakthrough is how the connection is managed. Historically, giving an AI access to a system meant relying on these really messy, scattered OAuth approvals.
Well, let me stop you there. When you say oath approvals, you mean those pop-ups where a user clicks, allow this app to access my Google Drive.
Yes, exactly. Or worse, individual developers generating long strings of text called personal access tokens and just hard-coding them into the AI's memory.
Oh, which goes right back to the digital ghost nightmare I mentioned at the top.
Yep.
If an employee leaves, but their personal security token is still baked into some AI agent's code, that agent is wandering around the network with a ghost's identity. That's a chief security officer's worst nightmare.
It is a massive liability. You can't run a business like that.
Right.
So what Anthropic is doing is pulling agent access directly into the enterprise's core identity infrastructure. So the systems like Okta or Active Directory.
Right, the stuff they already use for humans.
Exactly. The AI's permissions are now managed centrally, just like human employees would be. So when an agent requests data from Notion, the system doesn't rely on a hard-coded token anymore. It checks the central authority in real time to see if that specific agent operating in that specific context has the right clearance at that exact millisecond.
Wow. So if we step back and look at, AWS handling the decentralized discovery side and Anthropic handling the secure real-time identity side, it really feels like we are witnessing the birth of a totally new structural layer in software.
We absolutely are. We are watching the enterprise AI stack separate into highly durable layers. You have a model layer, which is the raw intelligence.
Yeah.
But now you have a resource discovery layer, an identity layer, a permissions layer.
Okay.
And the defensibility, like the true structural power in the market, is shifting to these control planes. The companies that own the identity and discovery routing are going to be in an incredibly dominant position, arguably even more so than the companies just providing the underlying intelligence.
Because models might eventually become like interchangeable commodities, right? But the security and routing infrastructure is the plumbing that actually holds the business together.
Precisely. The intelligence becomes a utility you just plug into the wall.
Huh.
The infrastructure becomes the competitive moat.
Okay, but this creates a totally new problem because we have just handed our brilliant new digital employee a corporate directory to find all the tools and a secure key card to instantly access them.
Yeah.
Now they are cleared to actually start doing the work. And because they are software, they don't do work at human speed.
No, they don't.
They start executing autonomous tasks at a volume that literally melts our current hardware. But I have to admit, I'm a bit confused here because I thought the entire AI revolution was just a race to buy more and more GPUs.
Right.
Why are tech giants suddenly obsessing over CPUs and network cables?
It comes down to understanding how an autonomous agent actually operates compared to a traditional chatbot. A chatbot takes your prompt, it generates a block of text on a GPU in one massive forward pass of computation, and then it stops. It is a single, isolated event. But an agent runs in continuous reasoning and action loops.
Like a constant internal monologue.
Yeah.
It thinks, it takes an action, it looks at the result of that action, and it thinks again.
Right. Let's look at the mechanics of that. It generates a thought on the GPU. Then it decides, I need to run a Python script to test this theory.
Mm-hmm.
It has to pause inference. It hands that script over to a CPU to actually execute the code.
Okay.
It waits for the result, reads the output, processes that data, and then sends it back to the GPU to decide what to do next. That constant ping-ponging back and forth, that heavy orchestration, requires a totally different compute stack.
Think of it like this. The GPU is the genius brain deciding to cook a complex 5-course meal.
Okay, I like that.
But the brain doesn't have hands. The CPU is the nervous system and the hands. It actually has to chop the onions, check the oven temperature, wait for the water to boil, and report back to the brain before the brain can decide the next step. If the hands are slow, it doesn't matter if the brain operates at the speed of light. The genius brain is just sitting there waiting for water to boil.
That is exactly the mechanism at play. And this is why NVIDIA is expanding its hardware stack so aggressively beyond just standard GPUs. They just moved their Grok 3 LPX into full production.
Oh, wow.
Yeah. This is an inference accelerator designed specifically for latency-sensitive agentic workloads.
Yeah.
In testing, it is hitting 3,400 output tokens per second on the Gemma 431 billion parameter model.
3,400 tokens a second.
Yeah.
That is incomprehensibly fast. That's essentially writing an entire novel in a matter of seconds. But how is an inference accelerator actually different from a normal GPU? What makes it so much faster?
It solves something called the von Neumann bottleneck.
Okay, what is that?
Well, in a traditional GPU, you have the processing cores, and you have the memory chips sitting next to them.
Right.
Moving the data back and forth between the memory and the processor takes more time and energy than the actual math itself. It's like having to walk to the library every time you need to remember a fact.
Uh,
The Grok 3 LPX essentially bakes the memory directly onto the compute cores. The data doesn't have to travel. It is right there.
that makes total sense. But why does the absolute speed of text generation matter so much if the agent is just quietly talking to a tool in the background? Like, the user isn't watching it type.
Because in those reasoning loops we talked about, the agent is constantly talking to itself. It needs to generate its internal thoughts, formulate its tool commands, and evaluate its next steps instantly.
Oh, I see.
If it takes even 1 second to generate a thought before calling a tool and has to do that 100 times to solve a complex coding problem,
Yeah.
your application just became painfully slow. Latency absolutely kills agentic workflows.
Got it. Speed of internal thought is just as important as the quality of thought when you were running, 100 micro decisions a minute. And you mentioned the CPU side of this earlier, the hands doing the chopping. What is happening on that front?
Well, NVIDIA also announced that SpaceX AI is deploying NVIDIA Vera CPUs specifically for their Grok workloads. And this is a massive architectural signal.
How so?
Agents consume incredible amounts of CPU resources between those model calls, simulating environments, processing unstructured data, compiling code, managing the orchestration. That is all CPU work. NVIDIA is proving that to win in the agent space, you cannot just sell the brains. You need highly specialized CPU and inference combinations to manage the hands.
But if you have all these specialized chips, right, the ultra-fast brains and the ultra-fast hands, and they're passing data back and forth millions of times a second, the roads connecting them have to be perfect.
Yes, and that brings us to the final piece of the hardware puzzle, which is Meta.
Okay.
They just disclosed 2 major infrastructure developments, Meta-ROSI and the MTIA 300. Meta-ROSI is a new transport protocol for running large AI clusters over commodity Ethernet.
ROSI stands for RDMA over Converged Ethernet, right?
That's right.
How does that actually speed things up in practice?
So Remote Direct Memory Access, or RDMA, is a way for computers to talk to each other by bypassing the operating system entirely. Normally, if chip A wants to send data to chip B, it goes through the CPU, down into the network stack, across the cable, and back up the stack on the other side.
Lots of traffic lights.
Lots of traffic lights. With RDMA, chip A literally reaches across the network and writes data directly into chip B's memory. It is essentially teleporting the data.
Oh, wow. So you are bypassing all the administrative bloat of a normal computer network.
Exactly. And to make that even faster, Meta's MTIA 300 is an accelerator chip that actually integrates the networking hardware directly into the silicon design itself.
Wait, they are baking the network cables directly into the silicon brain.
Essentially, yes. They are acknowledging that the communication bottleneck between the chips is now just as critical as the processing power within the chips.
Because we've just turbocharged this hardware, these agents are no longer just like drafting emails or summarizing meeting notes. The sheer speed allows them to attempt thousands of trial and error steps in seconds, which totally changes what a business is actually buying from these AI companies.
It really does.
We have to look at what these agents are actually producing now.
It is a profound shift in business models. For the last few years, businesses have essentially been buying smart assistants. They were buying tools that help human workers type faster or summarize documents or write boilerplate code.
It's like buying a highly intelligent laser-guided hammer.
Yeah.
It's a fantastic tool. It helps the carpenter swing perfectly every time, but at the end of the day, you still have to pay the carpenter to stand there, hold the hammer, and build the house.
Right. But what is happening right now is a transition from buying tools to buying outcomes. You aren't buying the hammer anymore. You are paying a system to hand you the keys to a finished, pre-built house. We call this workflow compression.
Workflow compression. How is this actually manifesting in the real world? Give me a concrete example.
Let's take the software development space. OpenAI and AWS just announced the availability of GPT 5.6 inside Kiro, which is AWS Era's spec-driven software development agent.
Okay.
The technical integration is impressive, but the real story here is the economic signal. OpenAI tested their GPT 5.6 Terra model on a rigorous coding benchmark called Terminal Bench 2.1 within this autonomous environment.
And what were the economic results?
The agent completed the software engineering tasks at roughly an 82% lower cost compared to previous benchmarks.
82%.
Yeah.
That isn't just a minor efficiency gain. You don't just shave 82% off a budget by having an engineer type faster. That fundamentally rewrites the economics of building software.
It completely rewrites them. And the architecture allows development teams to mix and match different tiers of the model based on the complexity of the task.
Wait, explain how that works. Why would you mix different models?
Because you don't need a genius architect to hammer a nail. You might use a hyper-advanced, expensive tier of GPT 5.6 for the complex architectural planning of the software. But once the plan is set, you deploy a faster, drastically cheaper tier for the routine building, compiling, and testing phases. You are managing a digital workforce to compress the time and cost it takes to go from a product idea to shipped code.
So it is automating the entire life cycle, not just giving autocomplete suggestions in an IDE. And I imagine it is not just software engineering that is seeing this compression. Any heavy analytical business process has to be a target.
Absolutely. Look at what Google Cloud is doing with their Migration Center. Moving a massive enterprise IT infrastructure into the cloud used to require months of manual work.
Oh, I know.
Teams of consultants walking around with clipboards, endless spreadsheet analysis, manually mapping out which on-premise servers talk to which databases.
Just a horrific amount of human hours spent on infrastructure discovery before you even migrate a single file.
Right, so Google just rolled out AI-powered quick assessments. It automates that entire process, the service mapping, the total cost of ownership modeling to predict cloud bills. It replaces those massive manual spreadsheets and armies of consultants with a system that autonomously assesses the environment and outputs the completed migration plan.
So again, the enterprise isn't buying a chat window that gives them advice on how to migrate. They are buying the completed migration assessment. They are buying the finished outcome.
Which raises an existential question for software developers. The best enterprise products going forward will be those that own a business process entirely, from the moment of human intent all the way to a verified result. If you are just a sauce wrapper that offers a chat window to query a database, you are going to be engineered out of the loop in 6 months.
Okay, this brings us to the ultimate question. If you are a developer or a business leader listening to this and you see AWS and Anthropic building the identity control plane, NVIDIA and Meta rebuilding the hardware stack for agent loops, and OpenAI and Google compressing entire workflows into finished outcomes, how do you actually build a defensible product today? Like, if models are just becoming interchangeable commodities that you plug into a workflow, where is the moat?
Well, we can see a very clear recurring pattern across all these major players. A new value chain has emerged, and it operates in a very specific 8-step sequence.
Walk me through those 8 steps.
Sure. It starts with human intent, what the user actually wants to do, then structured context. From there, it moves into agent discovery, followed by governed access.
Okay, that's 4.
Then finally, in step 5, you get to model reasoning. After the reasoning, it moves to tool execution, then verification, and it ends with a completed outcome.
Wait, that is fascinating. The actual AI model reasoning is just one single link sitting right in the middle of that 8-step chain.
Exactly. The model is just the engine. And the strategic value, the real money in defensibility, is migrating entirely to the middle and the right side of that chain.
To the governed access, the execution, and the verification.
Yes, that is where switching costs accumulate for a customer. That is where you capture proprietary workflow data.
Yeah.
That is where permissions and reliability are proven. If you are building an AI product today, you must build it with model independence in mind.
Meaning you shouldn't care if a customer wants to use GPT 5.6 or Claude or Gemini for the reasoning step. The intelligence layer should be entirely replaceable.
Keep the model replaceable, but strictly own the workflow. Own the human context. Own the identity and permissions architecture. If you own the system that captures a company's unique knowledge and securely turns it into a lasting digital asset, you have a product that cannot be easily replaced by whoever releases the smartest model next week.
It totally changes how you measure success, too. For the past few years, developers have been obsessing over price per token. How cheap can I get 1,000 words out of this model?
Right.
But if the model is just a commodity engine inside a larger workflow, that metric doesn't really matter to a business anymore.
It doesn't. The new metric that businesses care about is cost per finished asset.
Cost per finished asset.
Yes. What is the cost per completed bug-free software feature? What is the cost per accepted financial report? What is the cost per fully mapped cloud migration plan? You measure the elapsed production time, the human edits required, and the retry rate of the agent. You productize human intelligence and workflow management, not just raw model access.
This has been incredibly illuminating. We have laid out exactly how the industry is building the invisible infrastructure for these autonomous systems. We've explored how agents securely discover tools using standards like MCP and how they execute actions at mind-boggling speeds because of entirely new silicon architectures that integrate memory and networking right into the chips.
Hmm.
And we've seen how they're compressing months of work into days by delivering finished assets instead of just helpful hints.
Hmm.
But it leaves me with one final, frankly, somewhat unsettling thought. If these systems are compressing workflows to a fraction of the time, and they are executing reasoning and action loops at thousands of tokens per second across thousands of specialized processors, how does human oversight scale to match that velocity? If an agent can iterate a software design 100 times in a minute, human managers literally cannot read the code fast enough to approve it. Are we building infrastructure that inherently outpaces our physical ability to supervise the very outcomes they produce? That is all for today's episode of the Toshogu Podcast. If you enjoyed it, like this episode, subscribe and join us next time for the latest in AI. Until then, keep building what outlives you.